Okay.
Does not work.
Yeah, we'll see. Okay, hi guys. Seems a bit loud, but anyway. So I'm going to tell you a bit about how we used Pavo to do some visual modeling, and most of what I'm going to be telling, or actually all I'm going to be telling you about is a short section of what we published in this paper in Evolutionary Ecology, or BMC Evolutionary Ecology. So just to give you some background, so there's a species, a leafhopper species, that I'll show you a picture now of how they look like, but they're quite widely distributed over the entire, or quite widely distributed over South Africa. So they're the empty grey dots you can see there. And then these black dots you can see are possible host plants. So the host plants are kind of spread over quite patchily. So not a single one of these host plants cover the entire area. So the hypothesis here is that because you have this kind of mosaic of potential putative host plants, it is causing host shifts causing host shifts to form where the populations of leafhoppers are adapting locally to the host plants that are available to them. So in order to test this, there were 3 approaches in the paper. So host preference experiments, where you give them a choice to kind of, literally give them a choice in a jar. Do they prefer to go to the one or the other? Color matching, which is what I'll be talking about, and then body morphology. Are they physically better adapted to hiding on their particular ratio? So some of the ratios have thicker columns than the other ones. So do those hoppers have bigger bodies or smaller bodies, depending on what their host plants are? And so to obviously start off with, you have to get some data. So we use the spectrometer, and you get some reflectance data, relative reflectance data. So we're using white standards to kind of get a representation. And we did measurements of the leafhoppers and the host plants. And we had kind of 3 pairs of host plants. So host plants where you have minimal overlap between the 2 different host plants, like moderate overlap and high overlap. And the idea obviously here is also where you have lower overlap, you should see a stronger interaction. So there should be more, a bigger, stronger interaction of host shift where they're better adapted to their putative hosts. And so for everything here out, I only used Pavo and base R functions. And Pavo was, I think the associated paper with Pavo was published in 2013 by Maya and his co-authors. So first thing of all is you have to make sure that in the first column you have your wavelengths. So you can see there WL is the wavelengths, and basically just gives you, and every column after that's the measurements you have for that wavelength, the reflectance measurement. And then each column is just a different individual that you've measured. So first off, you import your data in your preferred method, whether it's re.csv or whatever, and then you can use the rspec as.rspec to kind of transform this data into the appropriate format. And I was quite new to R when I did this, and so I was incredibly stoked to learn about lapply and lists, because it made my life so much easier. And so you can do visual space, you can plot. So you can do a visual model using the vismodel function. And we used average bird vision because you need to use the appropriate kind of, the visual system you use for matching is quite important, because you want to use a visual system that's most appropriate. In this case, it was birds, because they're the most likely predators. And they're tetrachromats, so they have 4 independent channels for sensing color information or visual information. And you can plot them in visual space like you see here. And the closer together 2 points are in visual space, the more alike they are. So you can color match them by measuring those distances. And so to measure those distances, we use J&Ds, which are just noticeable differences. So that's the distance required, or the least amount of distance required to see a difference between those 2 points for 50% of the time. And then after that, so we got the distances, and actually most of the effort that I had to do was actually just getting the data in the correct format. So after that, I just basically added columns for which are the origin plants and where they were measured to, filtered through those until you get your shortest distances, basically. And we ended up doing 2-way repeated measures and novas. And you can see the data, we kind of look like that in the end. And as you can see here, we did you use AOV function, and then in the end we got this result. So you can see that in pretty much low range overlap and high range overlap, there was no interaction, no significant kind of result, except for in the moderate range overlap, where you can see that population was more closely matched with its putative host plant than the other guys who were more closely matched to their guys, even though they were still not well matched. So there is some evidence of host chef occurring, but it's not incredibly strong. So yeah, thanks.
So please catch up with Jeroen at the tea break to chat further about leaf hoppers. Next we have Peter Carmen, who's going to be telling us about